and other parts of the world, zinc is mined in many different areas. One of these is in a beautiful part of northern New York State at Balmat. And in this upper Adirondack mountain country around the zinc deposit, a mining community of pleasant homes has grown. Zinc was first noticed at Balmat by prospectors in 1838. But it was not until after extensive exploration by diamond drill that mines were developed and large-scale recovery of the ore begun in 1930. Today, at the corner of the shaft, or mine entrance, are clean, heated dressing rooms. Here, the miners change to their working clothes. The zinc ore found at the surface at Balmat is low grade, but rich deposits were discovered by diamond drill holes which intersected the downward projection of the surface outcropping. In addition to zinc, the ores mined at Balmat contain large amounts of iron and small amounts of lead and cadmium. Cages carrying 18 men each trip lower the men quickly and smoothly to the levels at which they work. For safety, each man wears a hard hat and steel-toed shoes, and each carries an electric battery lamp. At the Balmat zinc mine, the shaft extends over half a mile into the earth at a 40-degree angle. It was sunk at this inclination in order to be parallel to the downward trend of the ore bodies. The miners leave the man cage at concrete platforms at each working level, called shaft stations. From these extend the drifts or tunnels that lead to the stopes, the caverns from which the ore is taken. The temperature underground remains about 55 degrees Fahrenheit the year round. Ventilating doors that open at each level prevent fresh air which has been forced into the mine from escaping up the shaft until after it has circulated through all the workings. And into the stopes, gigantic man-made cavern higher than a skyscraper and as large as a city block, ceiling lost in blackness, great overhanging ledges dwarfing the men who created them. Distance from footwall to hanging wall higher than a 5-story building. It is difficult to imagine that this huge stope, from which hundreds of thousands of tons of ore have been mined, was once a tunnel large enough to admit only one man. To prevent any loose rock from falling unexpectedly while men are working, all walls are carefully scaled, and any loose rock is barred down as this miner is doing. But the limestone formation is so solid that no timbering is necessary. Safety is a prime consideration at all times. The ore broken by blasting is drawn off from the bottom of the stope through chutes. Here a miner is shoveling broken ore to clean off the bottom preparatory to drilling. In flat areas, scrapers are used to move the broken ore to places where it can be more easily handled. At each working level in the mine, there are several of these huge stopes from which the ore is mined. Each miner works his own heading or workplace. The staccato pounding of the compressed air drills echo and re-echo through the chamber. The ore at Balmat averages approximately 10% zinc, 1% lead, and 10% iron. The ore occurs as a replacement of ancient limestone formation. Ore bodies are irregular in shape, but tend to follow the direction of the limestone formation. And almost half a mile below the surface, as ore is mined, development work must be done to make new ore bodies acceptable for mining. This is done by starting drifts to those unexplored sections of the mine where the engineers believe new ore will be discovered. All drilling is done by pneumatic drills. 2 hoses are connected to the drill, one for compressed air for power, which is piped from a compressor plant on the surface. The other hose supplies dust-preventing water. The ore is drilled, the holes loaded with dynamite, and blasted. Water is forced through an opening in the drill to prevent the dust and to cool the drill bit. Drills are often mounted on a carrier called a jumbo. The cold, moist air from the drill forms a fog when exhausted into the warmer air of the mine. For every 6-foot advance of the drift, 60 bits are dulled. This means that the blacksmith shop at the mine head is kept busy resharpening bits, tempering them to the required hardness to cut the ore-bearing rock. In another part of the mine, electric blasting caps are prepared. Each miner carries this equipment in a box bearing his name. He checks it out during the shift and returns it to the stockroom before leaving the mine. explosive charges are loaded, wired, and then fired electrically at the end of the shift. In order that all smoke and fumes from the blast will be dissipated, miners do not return to this working place until the next shift. The next morning, mechanical loaders load the rock shot down the night before. After several hours of intense work, lunchtime is a welcome break. Dining rooms in the mine may not be fancy, but they are clean, dry, and electrically heated. Miners find the electric heaters good for toasting their sandwiches, too, while the men are eating and resting. Let's take a diagrammatic look-see at other mining operations. Once the men and their machines have completed the horizontal drift, raises, or almost vertical tunnels, are driven up from the drift at each end of the ore body. From the raises, grizzly subdrifts are extended into the ore body, and mining subdrifts above the grizzly level are driven to connect the two raises. As the ore is blasted down, it falls by gravity to the grizzly level. In the floor of the grizzly subdrift are steel beams spaced 10 inches apart. The large boulders of broken ore are further broken by a sledgehammer for ease in handling. Then the ore drops between the steel beams of the grizzly, the first screening operation in zinc mining. Beneath the grizzly is a chute in which ore is stored until it is to be loaded on a mine train. A pull on the gate at the bottom of the chute, and the broken ore piles into the mine cars, each of which carries approximately 3 tons. The loaded train, pulled by a 7-ton electric storage battery locomotive, now goes on its way toward the shaft. Near the shaft is a storage pocket, and as each car passes the mouth of the storage pocket, a wheel on the underside of the car body rolls up a rise on an elevated third rail. This causes the body to tip up, filling its load, and to return to an upright position. An entire train load can be dumped without stopping the forward motion of the train. Then the empty cars return for another load. The ore moves by gravity through the storage pocket to the loading pocket 100 feet below. An operator measures out 7-ton loads from the loading pocket, and the ore roars into the skip cars. Skip cars counterbalance each other like the weights on an old grandfather clock. As one goes up, the other comes down. Their speed is equal to traveling from ground level on Fifth Avenue to the top of the Empire State Building in 1 minute. Reaching the top of the shaft high above the ground, the skip dumps its load. The ore pours into the primary crusher building. In this building, the ore is crushed and screened, preparatory to separating the zinc from the small amounts of lead and the larger amount of pyrite associated with it.